What's happening, dogs? Mr. Allen here, getting ready to graph some tangent and cotangent functions here, which means you've probably already seen your sine and cosine graphs, even with some crazy transformations to them. So we're actually going to use what we know about our sine and cosine parent functions to help us get going with the tangent and cotangent here. So tangent of theta is equal to sine of theta divided by cosine of theta. We should know that from our unit circle, our quadrantals and things like that, right? We use sine over cosine to figure that stuff out. So let's go ahead for this one. I'm not going to answer any of these questions right now, period, amplitude, anything like that. We'll get that from the graph. But let's scale this thing out like we normally would for a sine or cosine graph. We got pi over 2, pi, 3 pi over 2, and 2 pi. And over here we'll get negative pi over 2, and we'll get negative pi. We'll go ahead and just do 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Cool. All right. So let's think about our values here. If I do 0, sine of 0, right, is 0. And cosine of 0 is 1. What's 0 divided by 1? It's 0. All right, so I have a point there. That's cool. How about pi over 2? Well, sine of pi over 2 is 1. Cosine of pi over 2 is 0. What's 1 divided by 0? That's undefined. So I need to put myself a nice little vertical asymptote right there. Okay. How about pi? Well, sine of pi is going to be 0, and cosine is going to be negative 1. What's 0 divided by negative 1? That's 0. Oh my goodness. Can you guys hear Jenny whining right now? She's whining. She wants to go outside. After this video, Jenny, all right? We'll go outside right after this video. Okay. She loves graph and trig, but we've been doing a bit of it, so she wants to go outside right now. Okay. Next one, 3 pi over 2. Well, sine of 3 pi over 2 is negative 1, but cosine is 0. Negative 1 divided by 0, undefined once again. There we go. And then 2 pi, that's going to be 0 divided by 1. Over here, if we get negative pi over 2, it's going to be the same kind of thing here. We're going to have ourselves, let's see here, that would be negative 1 for sine, because we're down here at the 3 pi over 2. And then divided by 0, it's going to be undefined. Okay. So we got a whole lot of asymptotes going on here. A lot of asymptotes. But what in the heck are we supposed to do with that, right? Let's think a little bit more. Okay. I'm going to add another point here. I'm going to do it in a different color. All right. We'll go green. Pi over 4. What is tangent of pi over 4? If we're thinking about unit circle, it's the sine and cosine are both root 2 over 2. Anything divided by itself is 1. And the same would go if I went back to negative pi over 4. I'd get myself negative 1. Over here, same thing's going to occur. I'm going to get a point right up here at 1 and down here. So if I just keep evaluating using the unit circle, we're going to see this occur. And if I were to plot a lot more points, you'd end up seeing a graph that looks something like this. Actually, I'll keep it in green here. We're going to get something like this, where it's kind of like this, almost looks like a cubic function, but it's not. All right? But it's got that nice S sort of, that's not an S, but whatever. A little squiggle shape to it, right? And we're just going to approach those asymptotes and come on down like that. Okay? Get nice and close to those asymptotes. So this one right here would be looking like something like this. It would continue on up, and there'd be some kind of an asymptote. Not some kind of, there would be an asymptote right here as well. All right? I didn't really continue that graph along very well. Oh, gosh. Now it's all smudged. Oh, I've ruined everything. This is terrible. It's okay. There we go. And then same thing with over here. So let's think about our information here now, okay? Let's think about that information. Our period. How often is this thing repeating itself? It looks like between these asymptotes, it's the same thing every single time, right? Well, what's the distance between negative pi over 2 and pi over 2? That's just pi. So our period here for our tangent function is pi, all right? My amplitude, much like if you've seen cosecant and secant yet, there is no amplitude here because it just keeps going up and it keeps going down. And amplitude is talking about how high up and how far down from the midline it goes. This just keeps going. So we really can't say amplitude. But you're usually going to see these types of questions anytime you're asked to graph, and it's up to you to say, like, no, there's no amplitude. Or like, we can't say that, right? It goes on forever and ever. Phase shift, none for this one, right? There's nothing moving left or right. Domain. So domain here gets kind of tricky to write. It's fun to write. I enjoy it. You might not. Whatever. All right, so it's all about what x cannot equal, because we can do all these x values except for these asymptotes. So some will have you say all real numbers and then also x cannot equal. I'm just an x cannot equal kind of guy. Okay, like you don't tell me that it's all real numbers and this, right? If I'm saying x cannot equal these things, I'm implying it equals everything else. That's just my 2 cents. If your teacher wants you to write some more stuff here, then do that. But this is like the general idea here. Okay, so I know that it cannot equal pi over 2. Pi over 2. But it also can't equal 3 pi over 2 and 5 pi over 2 and so on and so forth and negative pi over 2. So how do I figure that out? Well, I got to add in the spacing between these. These are pi apart. So if I add pi n times, where n is some integer, then I'm going to get all these different asymptotes. If I put a 1 in for n, I'm going to have 1 pi. 1 pi plus pi over 2, that's 3 pi over 2. And then if I put 2 in, I'm going to get the 5 pi over 2. If I had a negative 1, I'd get negative pi over 2. There we go. Bippity bop. Bippity boppity. All right, how about range? How about range? Never stops going down, never stops going up. Range is all real numbers, negative infinity to infinity. We'll just say all real numbers. I mean, that's pretty dope. That's fantastic. That's awesome for tangent right there. All right, Jenny really wants to go outside. I'm going to step away for just a sec and let her out. Okay, you want to go outside? Whew, there we go. All right. There's been a squirrel that's been taunting Jenny, all day. She wants to take care of that business. All right. So let's take care of this business here right now. All right. I want to make sure this thing is recording. I think it's recording. It's recording. Okay. So we got y equals cotangent of theta. Let's think about this in the same way that we just did with tangent, but cotangent, that's going to be cosine over sine. Right? But we can still use those values and figure that stuff out. Okay? So let's scale it the exact same way that we just did. So we got pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. Then we got 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. All right. Next up, let's think about our values and our asymptotes and things like that. Because I have a feeling the same kind of thing is going to occur here, maybe in different spots. But if we're dealing with those same values, we're going to have the 1 divided by 0 and 0 divided by 1 kind of thing going on. So for 0, all right, we got 0 there. Well, cosine is 1, sine is 0, so it's actually going to be undefined right here. How about pi over 2? Well, pi over 2, cosine is 0 and sine is 1, so we get 0. At pi, we got cosine is negative 1 and sine is 0, so negative 1 divided by 0, that's another asymptote right there. 3 pi over 2, we've got ourselves cosine is 0, sine is negative 1, so we get 0. And at 2 pi, same thing occurs that happened originally, right? I'm going to get cosine is 1, sine is 0, undefined. Okay. And I think you guys could probably guess what we're going to have an asymptote right there as well. Okay. Very good. And at negative pi over 2, we're going to have that value right there. All right. Next up, let's see here. We've got probably going to be something like that, right? But is it going to look exactly like that? Let's test this out. Okay, let's test this out. So we've got this right here is pi over 4. Oops, why did I do that? Hold on. Hold up. We're starting to write pi, as I said, pi over 4. Okay. Right here is pi over 4. Now, pi over 4, cosine and sine have the same value. It's root 2 over 2 and root 2 over 2, which is 1. So my point is still right up here, right? That value is the same here as it was here. But it's on like the left side of the graph instead of the right side. So we're going to have like a different kind of an S shape or squiggle or whatever you want to call it, right? And over here for 3 pi over 4, at 3 pi over 4, we've got, let's see here, we're in the second quadrant. So that means that sine is positive, but cosine's negative. They're the same value, but one's positive, one's negative. So we're at negative 1 now for this. There we go. So we're going to have that same kind of deal going on, but going the other direction and in a different chunk of the graph. As you can see, the asymptotes are staggered differently. So here, same kind of idea. We're going to have a point here, a point here. Nice, beautiful. Awesome. All right. Dope. Super dope. So there we go. We got ourselves a nice cotangent graph. We should probably answer some questions now, right? Yep. Our period. Well, our period appears to be the same dealio, right? The graph is repeating in these chunks of pi, so our period is pi. How about our amplitude? Well, it never stops going up or down, so no amplitude that we can say here. Phase shift. We didn't do any shifting here, so none. I'm not going to even get into some separate examples here. It would get so crazy on this thing. I'll do another video with some transformations of tangent and cotangent. All right. Domain. So what is x not allowed to equal? This one's actually kind of nice because it's at 0, but then it's every pi. So x cannot equal pi n, where n is some integer, positive or negative. I'd plug in 1, 2, 3, 4, 5, or 0, or -1, -2, whatever. Okay. My range is all real numbers. Y equals all reals. There we go. Nice, man. That was a lot. That was a lot going on there. Tangent and cotangent are kind of crazy. Really, any of these trig functions that have asymptotes, like our reciprocals, gets a little dicey in there. But when in doubt, plug in some familiar numbers into a function and see if you can get a picture, right? We plugged in pi over 4 because we knew from our unit circle values, or if you're a person that likes to draw triangles, that both cosine and sine are the same value at pi over 4, which gives us 1, which is a nice, easy number to work with, okay? So you can remember some of these patterns of how the cotangent function looks and the tangent function looks, and then deal with transformations from there. But if you ever get lost in the sauce, make sure to just plug in some numbers, some familiar ones, and try to, muscle your way through it. All right, there you go. That's it. That's dope. More graphing with tangent and cotangent to come. We'll do another video on that, and then maybe something else. We'll see. I don't know. I don't even know where you're at in this video process. This is fun, though. I'm having fun. I'm loving these trig functions. See you later.